In this video, we are focusing on factoring the greatest common factor. You have learned about the greatest common factor before, but you have not factored it out of an equation. Factoring a greatest common factor out of an equation is one step that we use to solve equations that are not linear, and this builds upon using the zero product property. Before we begin, try solving these three equations. If they are not on your paper, copy them to separate paper. If you get stuck, then figure out why you're stuck. Unpause the video when you're done. Are you ready? In the first equation, we get one solution, 9/8. I used inverse operations of addition and division to get this solution. In the second equation, we got two solutions, which makes sense because we have an x squared. I got 5 and -5. Either of these will make the equation true. I used the inverse operations of addition, division, and then the positive and negative square root. In this last problem, we get stuck. We could start by adding the 61 to both sides or subtracting the 2, but we are going to need to be able to factor this equation. I know you haven't learned this yet, but our goal is going to be to isolate 0, factor this quadratic, and then set each factor equal to 0 to find our solutions using the zero product property. In a lot of cases, factoring becomes much simpler if you factor out a greatest common factor first, and that's what this video focuses on. The greatest common factor is the largest common factor, meaning number and variable, that is in every term. You learned about this starting in 6th grade. So the greatest common factor between 6 and 15 is 3, because the factors, if you were to list them out, of 6 are 2 and 3, and the factors of 15 are 3, 5, and 15. Of course, 1 is also a factor. The greatest common factor of 8 and 36 is 4. The greatest common factor of 4, 8, and 9 is 1. Note that the greatest common factor could be one of the numbers themselves. If you were looking for the greatest common factor between 8 and 32, then 8 is a factor of both 8 and 32, so that's the greatest common factor. Remember, factor is multiplication, so it is a number that each number or term is divisible by. When we're looking at greatest common factors between variables with exponents, we need to first remember our exponent rule. X squared times x to the fourth is x to the sixth. This means that x to the first, x to the second, third, fourth, fifth, and sixth are all factors of x to the sixth. You do not think about what are the factors of the exponents. Rather, we know that this is x times x times x times x times x times x. So depending on how many x's you would be circling, x to the third times x to the third is x to the sixth, or x to the fourth times x squared is x to the sixth, or x times x to the fifth is x to the sixth. So working backwards, x to the eighth has factors x to the fifth times x to the third, and x to the third times x to the fourth gives us x to the seventh. We add exponents when we are multiplying like bases. Therefore, the greatest common factor between x squared and x to the fourth is x squared. X to the fourth and x to the third is x to the third, and x to the fourth is x to the fourth. We're almost ready to start factoring out a greatest common factor, but let's put our skills together and identify the greatest common factor for these next 3 terms sets. Pause the video, try them, and then unpause. Check your answers before moving on. Notice that since there is no common factor other than 1 between 2 and 3, our coefficient here is 1, similarly for this last one. Now, what does it mean to factor? Factoring out basically means undoing distributive property or undoing multiplication. So if we factored out x squared from x to the fifth, we would get x to the third, because together these multiply back to x to the fifth. If we were to factor out or take out an x from 3x squared, in other words, 3x squared is the same thing as x times what, we would know that we need a 3x in here. So 3x times x is 3x to the third. If we were factoring out a 5b squared from 15a b to the seventh, I know I need a factor of 3, I know I need a factor of a, and I know that I need 5 more factors of b in order to get back to our original answer. So it would be 3a b to the fifth. Now here's what we really want to do. We want to factor out a greatest common factor from an expression with more than one term. You could factor something out that's not the greatest common factor, but it will be more useful to know how to factor out the greatest common factor. So we're saying that this expression is equivalent to our greatest common factor, 2x, times something. And we know that that something, if we were to redistribute, would need two separate terms with a plus sign in them. We're basically undistributing. So 2x times 2 would give me back my 4x, and 2x times 3x would give me my 6x squared. So what's left in the parentheses is 2 plus 3x. The factored expression would look like this. Similarly, on the next one, we have that this expression is 5x to the third times something. We need the first term to equal 10x to the fourth, so we need a factor of 2 times 5, and we need one more x. And then we still need a plus 1, because without a plus 1, we would only get this term back if now we were to distribute this back in to get 10x to the fourth plus 5x to the third. So what's left is 2x plus 1. Let's see where this is useful. Before I show you where this is useful, let's fill in these blanks. When I see factor out the greatest common factor, I should think undistribute, or undo distributive property. This means I should identify the greatest common factor, then write the expression as a product of this greatest common factor and the remaining expression. Try these three problems, unpause the video, and then we'll move on. Notice that these are the same sets of terms that you identified the greatest common factor in earlier in part C, but now we're actually factoring it out of the expression. So check your answers. In this second case, we could have a negative 3m to the fifth if we wanted, but then this would be a negative 4 and a positive m to the third. That's still an equivalent expression. Also notice how we have a plus 1 here. If we didn't have a plus 1 here, we would only get the first two terms when we distribute back in. But now we want to see why we care. Factoring out the greatest common factor allows us to solve equations that we could not solve previously. So when I look at this equation, I wouldn't be able to take a square root, and if I add x to both sides, I would still get stuck with a square root in my answer. But now I can factor out the greatest common factor, x times 3x minus 1 equals 0. And because it equals 0, I can use the zero product property. We know that either this first factor or this second factor are equal to 0. So we have two solutions, either x equals 0 or x equals 1/3. And I got that from setting 3x minus 1 equal to 0. In the next example, again, we would get stuck if we couldn't pull out the greatest common factor. So I would write 2x squared, and what's left is I need one more x to get to 2x to the third, minus 5 to get to 10x squared. So I can set this factor equal to 0 or this factor equal to 0. X squared equals 0 gives me x equals 0. We don't have a positive and negative 0. Or x minus 5 equals 0. So, or x equals positive 5. Now, if you had not factored out the greatest common factor, and you had instead just factored out part of that, we would still be able to get the same solution. For example, if you factored it as x squared and left the 2x minus 10, you would still end up getting the same solutions. And if you were to check 0 and 5 in your original equation, we'd have 2 times 0 minus 10 times 0 equals 0, which is true. And you could check it with the 5 as well, and we would get the right solution. Let's see what you've learned. Try the last two problems, then unpause the video to see the solution. Remember that you can only use the zero product property if your equation equals 0, so you will need to set the equations equal to 0 first if they aren't. This is another step in helping us to learn to factor, and our next step will be to learn to not only factor out the greatest common factor, but factor a trinomial into more than one binomial. Here they are. The first equation has solutions x equals 0, or x equals 6, or x equals negative 6, and the second equation has solutions x equals 0, or x equals 1/2. Thanks for watching.